Welcome, everybody, and thank you so much for joining us on this Monday afternoon for what is our almost fourth Lunch and Learn during Members Week. My name is Caitlin O'Brien, and I'm here moderating with my colleague Lindsay Feistumel. And today we're going to be meeting our biogeochemistry team from the Academy's Patrick Center for Environmental Research. They're going to sort of show us what they do in the field, and after that, it looks like we're also going to get some sneak peeks of the labs back at the Academy. So with that in mind, we're going to go ahead and get started. As many of you know, we're on Zoom, and so we're going to quickly do some housekeeping to go through how to ask questions and how to participate, because at the end of the day, this session is really led by you, our members, to ask questions and engage. So how to use Zoom. If you don't have a video or microphone capabilities, feel free to use the chat function and type your questions there. Lindsay and I will help moderate and call your questions out, so Melissa, Tracy, and Joey will be able to answer them with their knowledge. You'll see the icon to open the chat at the bottom of your screen. Also at the bottom of your screen is the participants panel. If you would like to ask your questions directly to our scientists, feel free to open that panel and click the raise hand button. That will let Lindsay and I know you'd like to ask a question, and we can unmute your microphone for you so you can ask Melissa, Tracy, and Joey your questions firsthand. Now, to get started, before we go into the field with our scientists, let's introduce this fantastic biogeochemistry team. The team works together in a really incredible way, collecting water samples in the field and analyzing them in the lab at the Academy to figure out what is in our waterways, from salt to toxic contaminants. Melissa Bross manages the water chemistry monitoring for the Delaware River Watershed Initiative. Tracy Curran oversees field and lab projects and runs various lab instrumentation. Joey Heisinger contributes to all aspects of the section's field and lab activities and edited the wonderful video you're about to see. Paul Curie manages the nutrient lab of and is our chemistry guru with over 40 years of experience. And our biogeochemistry section lead is Dr. Marie Kurtz. She leads the interpretation and publication of results and develops new research projects and works on them to get funded. Paul and Maria are unable to join us today, but we wanted to be able to share the full team since this is definitely a team effort. Science is all about collaboration, and our biogeochemistry really takes the tea in collaborating to get this work done. So let's take a look at seeing them in the field. Just a moment to get this video started. Another click and hopefully that goes through. Great. Fantastic. That was so much fun to be able to go out in the field with our chemistry team. Who knew how much equipment, clothing, and also all the water and everything that went along with it. That was just so fantastic. So I want to be able to turn things over to the chemistry team, who it seems like is in the academy in our lab spaces, which, during members night, we're never able to go behind the scenes and get into their labs. So Lindsay and I will help moderate, and if you have questions, feel free to drop them in the chat or raise your hand and we'll turn them over to you. But for now, Melissa, Tracy, Joey, do you want to take a few moments to sort of introduce the spaces you're in now and also get us set up to talk all things biogeochemistry?
Hi, I'm Melissa. I'm just currently in one of our conference rooms with some of the field gear in case people have specific questions about the gear. I can kind of show a little bit more in depth in the video.
Excellent.
We're just in our water lab in 205 at the Academy. This is where we bring all the water samples after field collection and do the filtering and titrations for different analytes and everything else.
Excellent. So we do have one question already in our chat. How do you choose which sites to monitor?
So the sites are chosen for us for the video that you just saw at least. The main project we work on is the Delaware River Watershed Initiative. So the sites were chosen about 7.5 years ago by the head leads of the project. And we visit those sites every season. And there are 35 sites that we visit every season. So it's about 2 weeks every season that we're out in the field pretty much every day.
Did you say 37 sites, Melissa?
35.
35. Okay.
Yeah,
Wow, that's a
still
lot.
a lot. And they're all within the Delaware River watershed. So we are out near Kennett Square area, up in the Poconos, up in the New Jersey Highlands, and also in Philadelphia.
And you're the team that sort of are out all year long, all season long. I know some of our other Members Week activities have shown pictures of beautiful warmth, doing their field research, but you're the team that really is out there in the depths of winter in the stream with your waders on. Can you talk a little bit more about sort of what's the hardest part about field work besides, the temperatures?
Yeah, temperature is definitely very bad in the winter. We have very thick waders that we wear, lots of thermals, and extra pair of clothes in case we fall in, which has happened to I think all of us at least once. But there's really nothing else bad about field work. It's wonderful to get out into nature.
Yeah, I agree. Yeah, I guess the only thing I can think of is like when technology doesn't cooperate. That's really like the only time when it's frustrating is like something doesn't connect, like the computer isn't connecting to the river surveyor, or something isn't turning on. Other than that, yeah, it's great. We're really lucky to be able to do what we do.
Excellent. So sort of along those sort of river surveyor equipment, is that, Melissa, that's what's behind you right now. And so another question that we have along those lines is, do we only have temperature probes for continuous monitoring?
Yes, for these streams, we only have the temperature loggers that continuously monitor. They take a reading every 15 minutes. And actually have a little display. So the brackets that you see in the stream, we make them out of epoxy, and then we tie the logger onto the bracket with some string. And this is how they stay safe in the stream until we visit again.
And that is constantly sending data to your database and what you're sort of monitoring every single day, right? Is that how we're sort of interpreting?
It collects the data onto the little logger, and then we read the data off of here.
Okay, when you visit the site.
When we visit the site, yeah.
Okay. That's awesome. And so what kind of data is it collecting, besides temperature? We mentioned in our opening that there was like salts and toxic contaminants, but what else are you reading, and how does it really help you inform what the health of a water system is?
For this specifically, that's just for temperature. But we do have our YSI handheld probe, and this collects the pH, dissolved oxygen, which is obviously important because the organisms in the stream can't live without oxygen. It measures the salinity, conductivity of the streams and how much salts are in the stream, which always goes up in the winter due to road salts on sidewalks and roads.
Mm-hmm.
And it measures temperature as well. So it's another check that we can do.
Mm-hmm. And that's sort of what you're able to then process in the lab where Tracy, you and Joey are, right?
Right. Yeah.
Are you able to sort of share is it at the workbench that you guys work behind you, or?
Yes, it is. Yeah, this is just kind of, these obviously aren't samples, but kind of like this water cube is like what we would bring back, like full of stream water, and we would take it and use the syringe and filter for our filtered nutrients, which then get analyzed down the hall in the nutrient lab. And then there's also unfiltered nutrients that get analyzed for different parameters as far as nutrients go. Then we do cation analysis, anion analysis, total suspended solid filtering, and all our titrations, like for alkalinity, for chloride, which Melissa mentioned, and hardness. So yeah, a whole slew of things.
Wow, who knew? This is all, chemistry was not my area in any capacity. So it's just fascinating to sort of hear about it and learn about it today as well. And so we do have some more questions in the chat that I'm going to sort of pivot us a little bit. So from Dan, do you sample streams that are too big or deep to be weightable? If so, what equipment do you use for those larger water bodies?
All of them are weightable. There's pretty much only one that's a little suspect if the river is a slightly bit higher, and we just send Joey out because he's tall.
So Joey's the special equipment that you would use. That's too funny. So how often are you visiting these sites? You said it was like every season for 2 weeks, or is it 4 times a year?
4 times a year, yes.
Okay. And how long have you been visiting these same sites? Is it for as long as the DRWI project has been happening? So how many years would that be?
Yeah, so 7 years, starting in the fall. So I guess 7 years right now would be how long it's been.
Excellent.
So these sites are pretty much our second home at this point.
Have you noticed sort of changes over the past 7 years just by visiting, either improvements or degradation, or?
They've really stayed stable. The only thing, like I said before, is the salts. So the conductivity, the chloride, those have been rising, especially in the winter. But we've seen a trend over the years as well, besides seasonally.
Okay. So like each winter it's getting higher and higher because of uses of road salt. That's interesting.
And that's not good for the organisms that live in the water because it's fresh water. So if there's more salts going into the water, that's changing the chemistry, which isn't good for the organisms who are more used to fresh water than salt water.
That makes sense. We do have another question in the chat, in the sense of sort of, are you analyzing data yet from the sites that you've sort of collected already? Or were you able to collect data this season so far with everything happening, and are you analyzing in it yet?
Yeah, we were able to get out. We were able to get out for, the end of summer and get finished most sites for summer sampling. We didn't make it to any of the northern, Pocono sites, but everything, within 2-ish hours away, we were able to visit and take samples. Yeah, and Joey and Melissa have both been in here more often than me, filtering and taking care of everything in the lab. So very thankful for that.
And sort of along those lines of analyzing, if you have a particularly unhealthy stream, what would you expect to see in your nutrient analysis?
For nutrients, just higher values. So we analyze for nitrates, nitrites, and phosphorus and ammonia. So when we are near some of our sites that are farmland, then the nitrates are really high just due to fertilizing the farms.
Mm-hmm.
And then in the urban area, it's also a little bit high as well, just because of the dense population and runoff. So yeah, we would just see the higher values when we run the analyses. So using that in conjunction with everything else we analyze, we can kind of paint a picture as to how healthy or unhealthy the stream is.
Mm-hmm. Excellent. And so on the flip side, what would be sort of like a super healthy stream analysis? And have you encountered like a really healthy stream in sort of your data collections?
Yeah, all the sites up in the Poconos, they're what we call the headwaters. So they should be pristine. They should be the nice, clear, wonderful streams that we want to protect at all costs, which is one reason why we're doing this study. So all of those are pretty much nice, I guess, what would you call it? Like our goal for like down in Philadelphia, we want it to be like those headwaters one day.
One day soon, and your work is definitely going to help us get there one step at a time. So we do have one question from Todd. Have you ever found anything crazy at one of your field sites?
Definitely animal skeletons. We found some of those.
That's pretty cool. Anything else, or is there any sort of like barriers? Like I know in one of our other conversations, there's a lot of talk about like how cows get in the way of a lot of field work. Is that something that encounters that you like your arch nemesis of field work?
No cows.
No cows. I feel like fallen trees tend to be like a big barrier that we're like, oh no, a tree fell and you can't get to what your temperature logger, or you can't get to the site where you need to measure discharge. So we're always trying to figure out ways around, these unexpected things that happen.
So lots of creative thinking goes into when you actually get out onto the field sites.
Yeah.
Excellent. So we do have another question. Are the chemistries being done with other teams looking at different biota levels, or is it just chemistry?
Yeah, I mean, I guess the chemistry samples that we take and the data that we get from those samples all go into a database along with like all the biotic data, like macroinvertebrates, fish data, algae data, and then we try to make correlations between all of those together to see like if we can track changes, or like if something like a chemistry parameter like there's a spike in chloride at a certain point in time. Does that correlate with anything happening to macroinvertebrates at that time? Like, is there only a certain number of species, or yeah, so it's all very connected. It just not in that moment of time when we sample. We have to look at the big picture with all the little pieces afterwards.
It's really, again, rooted in that sort of collaboration efforts between all of the departments and collections in the academy and within the Patrick Center. You sort of have that 30,000 feet view to understand what's happening in the entire ecosystem, where a lot of other departments sort of zero in on specific either fishes or macroinvertebrates or algae, where you have that sort of that overall ecosystem view, which is really amazing. So we're coming to 1 o'clock, but one question that I know that we like to ask in all of our sessions is sort of, how did each of you end up in this line of work? Sort of what was your path in that sense? We have a lot of families and kids on the call as well. So we'd love to sort of hear a little bit about your journey from each of you.
Well, my parents always took me hiking and bird watching when I was a kid, so I've always had a love and connection with nature. And then in college, I took an environmental studies course, and just learning about people like Rachel Carson, who helped ban DDT. I was like, I want to be that hero and save the world. So I chose environmental science as my major and never looked back.
Excellent.
So I always grew up enjoying like the woods and being outdoors. And I like really got like a passion for like conservation in high school. So then going into college, I pursued biology. And then for 3 years, I worked down in Florida in lake and wetlands management, and then moved up here and started working for the academy.
Excellent.
Yeah, so similarly to Joey, I did biology as my major. Wasn't sure what I was going to do with it. Then, always had an interest in the outdoors and in nature, like spent my childhood outdoors in the woods. So, yeah, it just all kind of made sense. So, it is something that's important. It's something that we could make a difference in. Yeah, and it's also a job that makes you feel good about what you're doing. Like you can leave at the end of the day and feel like you did something beneficial or you're working towards a greater good. Yeah, so it's great.
Excellent. Thank you all for sharing that. And sort of along those lines, what is your favorite part of the job? Tracy, you really sort of eloquently said that you're making a difference each day, but is there other aspects that are your favorite job? Like a favorite piece of equipment or a favorite sort of data analysis tool, or if each of you could sort of share that, that would be wonderful.
I think for me, going out in the field is definitely my favorite part of the job. I think just like getting outside of filling in, like seeing really like what we're working towards in the lab, like is a really fun part of the job.
Mm-hmm.
Yeah, that is probably the best. I do also like making the connection between, a certain site and then like what the chemistry says. Like if you're there in the winter and you see a lot of road salt and then you go analyze the sample and see that the chloride is really, really high, you're like, oh, I know why that's happening. Or, it's just nice to be like, yes, I was here on this day and saw this and this all makes sense. I don't know. It's nice to see it all fall into place.
Yeah, of course, field work is great. And when I'm not in the field, I run some of the nutrient analyzers with Paul. So gaining all the knowledge from him since he's been here for like 45 years, that's probably one of my favorite parts too.
Excellent. Thank you. And so coming back a little bit to sort of the larger picture on sort of how your work sort of feeds into the Delaware River Watershed Initiative, could you speak to a little bit more sort of on the overall goal of that project and how chemistry sort of fits within this larger multi-organizational, multi-site project?
Yeah, so there are a lot of what we call project sites. So either farms or other areas, they put up buffers around the streams so that, like we said, cows don't go into the streams, or they put up fences so that the animals don't go into the streams. When that doesn't happen, there's less poo in the water, which means less nutrients. So our sites are to see how those project sites are working out, if having that fence up is actually being beneficial to the water or not.
Mm-hmm.
And then besides us, there's a multitude of other organizations that are also taking samples throughout the watershed. So all the data together is just figuring out the health of the watershed, where more projects could be in place to help improve the water quality. And yeah, just making sure that we have healthy water for us, since we do get our drinking water from the Delaware and the Schuylkill. So everything upstream, if that's not clean, then by the time it gets to us, we have to do a lot of work to clean the water. Mm-hmm. And if we can make upstream a little bit better, then we'll spend less money cleaning the water too.
Excellent, thank you. Turning it to the members in our audience, are there any other questions? Are there any raised hands, chats? And the new questions in our chat, Lindsay, are you seeing any hands raised? Okay, that's not a problem. We'll keep going. You sort of, we've covered sort of your journey into the academy, what the DRWI is doing, sort of your favorite parts, but what also looking to the future on sort of your work? What are some other projects that are coming down the line, if any, or are you sort of continuing to work within the DRWI and that monitoring?
So we have a new project that was supposed to start this fall, but because of COVID, It has been moved to next fall, I believe, and we'll be testing for PFAS in different streams around Philadelphia. And that's the new forever chemical that everybody is worried about. That is mostly in like firefighter foam. So around military bases, it's in high concentrations from all of their different drills. But it's also in things like our Gore-Tex clothing to make it water resistant, in our pans to make them non-stick, in potato chip bags so that the chips don't stick to the bag. So there are these chemicals that are in everything that you don't think that they're in, and they're just making their way into the streams. So we're going to do a big study next year to see the concentrations in some streams around Philadelphia.
Excellent. Well, that's fantastic. Is that sort of like in northern Philly, or is it just sort of in the whole surrounding county, or where have you already picked out your sites, and are they different from the ones that you're monitoring in the DRWI?
Yeah, they're different. Tracy, they're all around Willow Grove, right? Near that military base up there.
That's what I was gonna say, yeah.
Where again? I'm sorry.
Sorry, Willow Grove military base.
Okay. Why did you pick that site?
Well, Marie, our leader, picked that site, but mainly just because of the firefighting foam and that just running right into the water in that area. So that's an area where there's high concentrations.
Okay, that makes sense. All right, we have sort of come up to our 1 o'clock hour. Are there any sort of last remaining questions from our members who are joining us today? If not, Melissa, Joey, Tracy, is there anything else that you want to share with folks sort of about your work and or about your labs, or just sort of anything that we haven't been able to talk about yet?
No, I think we covered everything.
Excellent, excellent. Well, one last call for questions in the chat or for raising hands. Lindsay, are you seeing any hands raised? All right. Well, thank you all so very much for joining us for our Lunch and Learn on a Monday afternoon. We are so grateful. And thank you so much, Melissa, Tracy, and Joey, for sort of taking us out onto the field and then back to the Academy. We really gratefully or graciously are really thankful for that. We miss each and every one of you from being able to be at the Academy for Members Night, and we hope that next year we'll be able to welcome you in person. And thank you also for your membership. With you, we are a force for nature, and because of you, our science, like that of Melissa, Tracy, and Joey, never stopped. Their work never stopped because of your membership. And so thank you very much. And we look forward to seeing you throughout our other Lunch and Learns and our virtual collection tours during Members Week. Thank you again for joining us, and feel free to email membership@ansp.org with any questions that may come afterwards. And then Melissa, Tracy, and Joey will be happy to answer any of them. Thank you again, and enjoy the rest of your day. Bye.